Hello everybody, welcome to the video on loops. So loops are a foundational tool in computer science. It's a fundamental concept, and loops are extremely powerful, and they will be one of the most important tools that we will have this semester. I should say that we can't really unleash much of their power in this video because this is an introductory video. So by the end of this video, you may or may not see how they can be so powerful. But just take it on faith from me that loops will be probably the most powerful tool we will have, especially when you use them in conjunction with things like if statements and later vectors, which we haven't gotten to yet. So I should say that with great power comes great difficulty, unfortunately. So loops, especially when you're doing sophisticated things with them, they take quite a bit of getting used to. It's a difficult concept to learn how to use. So let me just say that as fair warning up front that if you haven't found this course challenging so far, that's fine. But be prepared to find it challenging once we've really gotten loops under our belt. So if you haven't been challenged yet, your first big challenge may very well come with loops. So of course I'm here to help you, so I will do my best to help you understand what they're doing and why they are so powerful. But I can only do so much. Okay, you are learning a new language, and learning a new language is difficult and time consuming. So you just can't learn German overnight, for example. Okay, you can't learn a new language in a weekend. It takes time and it takes perseverance. So just be prepared to have to power through some of this material here. Loops take getting used to. You have to be willing to simply keep trying to program with them. And after a couple of weeks, I think you will understand them pretty well. And by the time we're done with our C++ portion of the course, you will understand them extremely well. Here's the motivation of why we might need a loop. Suppose you are writing a program that lets a user play blackjack against other players. And perhaps the table has a $10,000 limit so that you can win at most $10,000. You would somehow need to translate this English into C++. As long as the user still has money and their winnings haven't gotten past $10,000, let them keep playing the game. So you need to somehow write this in C++. As long as money is bigger than zero, so they have some money. And also, they haven't won too much. Their winnings are less than 10 grand. Let them play blackjack. Okay? So the way this would work is you would run the blackjack code, and then when you get to this close brace down here, you would simply check if this is still true. Do they still have money? And have they still not won enough? And if that's true, you would let this code run again. And after this code is done running, you would get down to this closing brace and then check if this condition is still true. And if it is, let them play again, etc. Okay, this keeps running and running and running until either they run out of money or they win too much. So you make this statement false, in other words. That's the idea behind a loop. So a loop occurs whenever you find yourself using the phrase as long as in English, or sometimes the phrase until. So the word if in English translates directly to if in C++. That's pretty nice. It's just an exact translation. The word otherwise translates as else. The phrase as long as translates as the word while in C++. So the way you will code the phrase as long as is with the word while. Here is the syntax of a while loop. So while you have some Boolean statement, run some code. So as long as this Boolean statement here is true, this code will run. It will run repeatedly. It will run until this Boolean statement becomes false. So what happens here is, when the computer gets to this in the code, it will check whether or not this Boolean statement is true. If this Boolean statement is not true, the computer just skips right to this close brace down here. The computer just skips everything. If this Boolean statement is true, the computer will run this code. When the computer gets down to this close brace, it will ask itself, is this statement still true? If that statement is still true, the computer will run this code again. The computer will then again get down to this close brace and ask, is this statement true? And if it is, the computer will run this code again. Okay? So in other words, this code will loop. Yes? Hence the word loop. So a while loop allows you to run the same code over and over again. You allow the program to loop back on itself. So as I said a second ago, the code inside the braces will run over and over again until this Boolean statement becomes false. Once the statement becomes false, you stop looping that code, and now you just move past this close brace here to whatever comes next. So essentially, a while statement is like an if statement. It's just that a while will keep running so long as the Boolean statement is true. If statements run at most once. Okay? The code inside of an if statement either runs once or not at all. A while statement is different. A while statement, it still has this Boolean statement here, but you will run this code inside of the while statement as many times as necessary until this statement here becomes false. So a loop is kind of like an if statement that can run multiple times. So that's a typo there, right? That can run multiple times. Sorry for the poor English. Here's an example of a loop. I'm missing a semicolon. Okay, well, that's all right. So let me start by setting x equal to -1. Now the computer gets here and the computer reads, as long as x is less than or equal to 0, do this. Do this code. And so notice that at this point in the code, x is equal to -1, which is less than or equal to 0. So I will come in here, I will print to the screen, enter a positive number, and then I will get a number from the user. So as soon as I get a number from the user, I reach this end brace. So what the computer does is it jumps back up here to the top and asks, is this still true? If that statement is not still true, the computer just moves on from the loop. It just starts, goes right back to this end brace, and then does whatever's next. But if this statement is still true, the computer will run this code again. So let's say that x is -1, I go in here, and suppose the user enters -5. -5 is less than or equal to 0. Therefore, this statement is still true. Therefore, the computer will run this code again. If the user enters a -8, well, -8 is less than or equal to 0. So the computer will run this code again. Okay? So notice the computer will run this code as long as the user gives the computer 0 or a negative number. That's what this code does. So in particular, if for whatever reason you really want the user to give you something positive, this loop will do that for you. This loop will force the user to give you a positive number, or the code just won't move on. Okay? So that's what this little introductory loop does. Here's another example. This shows how you can loop until a user tells you not to loop anymore. So let me just set response equal to 1. So response is equal to 1. So I will go into the code here. I will see out hi. And then I'll tell the user, hey, do you want me to greet you again? Enter 1 for yes and any other number for no. And I'll get their response. So if they enter 1, then right here at the brace, the computer will check, does response still equal 1? And if so, the computer will run this code again. And so if the user enters 1 again, it will just run this code again, and so on, right? So the code will keep doing this as long as the user keeps putting 1 in there. But excuse me. But suppose that right here, the user enters a 4. Well, 4 is not equal to 1. Therefore, you've made this statement false. So as soon as they enter 4, I don't loop. I don't go back to the top of this. I just move on, starting at this end brace here. So here's how you can set up a scenario where something happens until the user tells you not to have it happen anymore. So you can literally set it up so that, if you're writing a game program where you want to allow the user to play as many times as they want, but then tell you when they want to stop, you can set up code that will do that. You can say, hey, do you want to play again? Enter 1 for yes, 2 for no, or something. And you can break out of the loop based on what the user tells you. Yeah, so let me go back to this date program from the previous video, or 2 videos ago, I forget, and show you how we can use loops there. So let's see here. Yeah, I already have the date program in. So remember how this works. So whatever, the woman that I'm asking out enters various things. She might say yes. Much more likely, she will enter no. And then I ask follow-up questions, like my only feeling for you is pity. Okay, whatever, that's fine. You have feelings for me. That's fine. So, but notice that if she enters something I don't like that, the code says invalid input, please try again. But notice the code has stopped. She can't try again. Okay, I'm trying to type right now, but nothing comes up because the code is done running. So even though I've said invalid input, please try again, there's no way for her to try again. So how can we fix that? How can we force her to actually enter something that I want? And so let me just come back up here and point out that right after she gives me some input, that's where I would like to check whether or not she gave me something I like. I want her to type yes, or no, or stop asking me. Those are the 5 things I want her to type. So let's just force her to do that. So let me do that here. So I copied all that. I'm just going to erase this. Okay, so let's read this in English. As long as her input's not yes, also not yes capital, also not no, also not no capital, also not stop asking me, okay? As long as she gives me something besides those 5 things, I'm going to tell her. Invalid input. Oh, I guess I say please try again. And then I let her try again. Okay? So now, what's going to happen? As soon as she types something in, like blarg, whatever, notice blarg is not something I like. Therefore, this statement here is true. Blarg has the property that it's not yes, it's not yes, it's not no, not stop asking me. Okay? Therefore, that while statement, Boolean statement, is initially true, and this says invalid input, please try again. So suppose she says something else that again I don't like. I want a yes or no, etc. It'll say invalid, please try again. Okay? So notice, as long as she says something I don't like, I'll tell her I don't like it and force her to input something else. Okay? And this will go on as many times as long as she enters something I don't like, it'll keep prompting her to try. So this is a really nice use of loops. It's nice to force somebody to give you something that you want. Okay, you are not going to let the code move on until they give you something you want. So notice now if I hit yes, now we break out of the loop. because now this becomes false, okay? So if input is yes, then the statement yes not equal to yes, that's a false statement now, okay? So let me just say that again. If input becomes little yes, then now this statement here is false, right? Yes not equal yes is a false statement. Therefore, the overall statement is false, and I break out of the loop, and I start right here, and I just keep trucking through the code. So since I inputted yes, now I'm doing this, just like before. So that's how we can fix the date program to actually make somebody say something we want before moving on in the code. Okay. I want to show you two more examples and issue one warning, and then we will be done. So consider this use of a loop. Suppose you want to write a program in which the user enters as many numbers as they want, and you compute the sum. So the user enters 2, 7, 5, 3, 3, 10, whatever, and you compute the addition of all of those numbers. What would that look like? Here's a sample of what it might look like. So I'm going to create a variable that lets them enter things and a sum variable that keeps track of their addition. So notice I initialize sum to 0 because at the beginning, when there are no numbers, right, my sum is 0. There's nothing added yet. So notice this cout statement. It says enter a number, enter a non-number character when you are done. Okay, now check out this loop. This is pretty nice. So it says while you are c-inning a number, do some stuff. And I should say that this statement here doesn't look Boolean. Okay, a Boolean statement is like x equal 1 or x plus y less than 7. Is that true? You know? So this doesn't look like this. This looks like a command. Get a number from the user is what it looks like. And commands are not Boolean. But this actually is a Boolean statement here because number, this num variable here, is defined to be an integer. So what this is saying is, it's saying as long as the user is giving me an integer, then please place that integer inside num and go inside this loop. But if the user enters like a t, well, a t is not an integer. So this statement here becomes false because you're not c-inning an integer anymore. So if you enter a t or an s or something, you will break out of that loop. So let's now examine the logic of what's inside the loop. Let's say the user enters a 5 right here. So the user gave you an integer, therefore the statement is true. 5 is now inside of num. The value of num is 5. So on my first pass through the loop, sum used to be 0, right? Sum is 0. Sum is now sum plus num. So since sum is 0 currently, that means that sum is 0 plus number value, which I just said was 5. So the current value of sum now is 5. And then I say, hey, enter a number, enter a non-number character when you are done. So now the user might enter a 7. Well, a 7 is an integer, therefore this statement is true. Therefore 7 becomes the value of num. And now remember, the value of sum is 5 now, because they started by entering a 5. So the new updated value of sum is old value of sum, which is 5, plus the current value of number, which is 7. So sum now becomes 12. And so on. Okay, so now if the user enters a 13 right here, well now the value of sum, is the old value of sum, which was 12, plus the new value of number, which is 13, and sum becomes 25. So here's a way that loops let you sort of keep track of information without using any memory on some level, okay? Because as the user is giving you numbers, you're not keeping track of what they gave you. So every time you enter a new number value, right, the old number value is lost because you were overwriting the value of num. However, the sum variable is able to keep up with that by simply taking its old value of itself and adding this new value you gave it. So if I run this and I enter 2, 3, 7, 5, whatever, this will just add up those numbers until I hit the letter D or R or something, and then this statement will become false and I will break out of the loop. So I encourage you to put this code inside your compiler yourself and see what it does, to see that it does exactly what I just said. But here's a nice way to use a loop to let people just enter as much stuff as they want, and then you can break out of it by letting them enter something that's not an integer, for example. Okay, this we will use lots of times during the semester. It's not clear now why this is useful, but sometimes you want a loop to run just a fixed number of times. So maybe you want a loop to run 10 times. It's not clear now why, but maybe that's what you want. One way to do that is with what is called a counter variable. So I've actually called it counter here. So let's look at the logic of this. I set counter equal to 1. 1 is certainly less than or equal to 10. Okay, so I go inside the loop, I tell you all hi, and then I increase the value of counter by 1, so that counter is now 2. Well, 2 is less than or equal to 10, so I'll run this code again, this high class, and then I will update the value of counter again to 3, and so on, okay? So you can see that since counter starts at 1, I'm upping the value of counter by 1 every pass through the loop, and I keep going until I hit 10, that this loop will run 10 times. So if you know ahead of time, oh, I want this loop to run 15 times, whatever, you can make it do that by letting your Boolean statement contain a statement about a counter variable whose value you update as you go. So if I wanted this loop to run 30 times, I would have just initialized counter to 1 and then said, oh, go until 30. And then counter becomes 2, becomes 3, becomes 4, becomes 5, becomes 6, etc., all the way up until 30. But as soon as counter becomes 31, this statement now becomes false and I don't run the loop anymore. I break out of there. So let me just put that code in here so we can watch it run. Got to get rid of all this. Okay, so int counter is 1, while counter less than or equal to 10, hi, and then up the value by 1. Notice this runs 10 times. I didn't put any sort of formatting there, so let me do that. Okay, so there you go. And just to make sure we all understand what's happening here, let me put one more piece of information here. So this is the counter. So let me actually force this thing to tell you which pass-through of the loop we're on. Through the loop. Okay, so the English here won't be very good, but it says this is the first pass through the loop, hi. This is the second pass through the loop, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, okay? So the counter variable really is just keeping track of which iteration of this loop you're on. So when counter is 7, you're on the 7th pass through the loop. When counter is 4, you're on the 4th pass through the loop, etc. Okay, so let me end with a warning, and the warning is not to use infinite loops. And so let me just show you the example that's in the slides. Let me just make one change here. Okay, so I erased one line of code, that counter plus plus. If we were in class right now, and let me go ahead and get rid of this for a second. If we were in class, I would ask you what you think happens here. But if you think about it for a couple of minutes, it's not too hard to see what will happen. And let me run the code so we can see. It's all right, so you can see what's happening here. It's just outputting high. I mean, you see how much I have to scroll to get back to the top? It outputted like thousands of highs, okay? So why did it do that? Why didn't it stop just like it did earlier? Earlier it only printed 10 highs and then it stopped. So what's the difference now? Well, the difference now, let's just trace through the code. Counter is 1. As long as counter is less than or equal to 10, print high to the screen. And then you get to the end brace and check, is counter still less than or equal to 10? Whoops. Is counter still less than or equal to 10? And of course it is, because you haven't changed the value, right? Counter was 1 at the beginning of the code. It's still 1 when you pass through the loop the first time, and so you run the loop again. So after the second time you run the loop, you ask, is counter still 1? Is counter still less than or equal to 10? And of course it is, because it's still 1, okay? So the difference between this code and what I had a second ago is that this code here, with this line in there, updates the value of counter. So you change the value of that variable. So with this code, there's hope of this statement eventually becoming false, and therefore you will break out of the loop. But with this gone, you never change the value of counter inside of the loop. So once you're in here, you never escape. Okay, the only way you escape is if eventually the value of counter becomes 11 or bigger. So like by the same token, if I did this, if I decrease the value of counter by 1 every time, that's still a loop that runs forever. So now counter is 1, then counter becomes 0, then counter becomes -1, etc. So you never become bigger than 10, therefore you never break out of this condition. Okay, so this is called an infinite loop. Infinite loops are bad. You really shouldn't have them in your code. There's some slight caveats to that statement, okay, but generally you shouldn't have an infinite loop, because what will happen is it will just do nonsense like this. It will just keep running essentially until your computer is out of memory, okay, or of course you hit the stop button, right? But basically, there's no good reason to have your code just run infinitely until you run out of memory. Okay, so you should be careful about this. Make sure that there's some way to make it possible to break out of your loop. So again, if I never mess with the value of counter inside of the loop, there's no way to make this statement false. So I will never break out. Okay, so that's the example I want to close with, and that's what I have here. Here's the infinite loop. Infinite loops are bad. Okay, so be careful. So that's the end for my introduction to loops. As I say, it may not be clear yet why they're so powerful, but rest assured, when you use loops inside of loops, with if statements, with functions, with vectors, etc., they are extremely powerful. So now you've seen some sort of some baby step examples. So you've seen loops that sort of check that, like this, that check that the input of something is valid. You've seen loops that can loop a fixed number of times. So if you want something to run 15 times, you can do it, okay? These are sort of baby steps, and starting in the next video, we will ratchet these up to more advanced examples. But that's all I have for now.